They make Clonex and some other products. I know quite a bit about plant nutrition. I made some of the very first biohydroponic fertilizers where I combined the minerals and the organic biostimulants. But now it's kind of fun because instead of making special recipes and putting in a bottle, I'm actually going to be able to talk to you about the raw ingredients that are in the products that you're buying now. And I can show you how to fine-tune the feeding schedule that you already have without exchanging anything, without having to change the way you're growing. The idea is we want to make improvements to your growth. And the way we do that is by really understanding the needs of the plant. So then we get into a strategy of growing called spoon feeding, where we're giving the plant exactly what it needs when it needs it. So that way we can steer the crop. We can make it a little more vegetative, we can make it a little more generative. If we know that a hot time of the summer is coming, we can literally condition the plant against stress before the stress gets there. So the plant goes through it faster and doesn't stall out. We can show you how to unstall your plant. If things are developing and all of a sudden they just don't seem to be filling in anymore or growing anymore, it could be a hidden hunger. And I'll show you today how to identify that. And just give a 1/16 of a teaspoon of, say, potassium, just enough to get the sugars flowing back to the flowers where the plant needs it the most. So the idea is making small changes for small improvements for the way that you're growing right now. So I'm going to have to ask you a couple of questions to get an idea of the audience here. How many of you are you growing in soil or hydroponics? How many are going in hydroponics? Okay. How many in soil? Okay. Lots of soil. Are any of you doing all organic, 100% organic fertilizer? Okay. The rest of it is kind of a combination? Okay. All right, I get an idea. For growing mediums, when you're growing in soil, do you mean actually potting soil or like a soilless mix? Like Pro Mix or other cocoa? Co-mix, cocoa. Any of you growing in cocoa? Cocoa fiber? Okay, we've got a pretty good mix. There's something for everybody today then. So this will be a good one. Now when I make the presentations, this is live, I welcome questions. You don't have to wait to the end for questions and answers. We will have time at the end. But if there's anything along the way here, you have a question, go ahead and interrupt me, raise your hand, or blurt it out. I don't mind. This isn't a canned presentation. I'm here for you, so I'm going to answer your questions. I want to find out what your needs are and help you to go away with something that you can apply tonight or this weekend to your garden. So please ask questions if you have them as we go along. Okay, so might as well start at the beginning. We're not going to really go too much into the environment. I assume you all are using full spectrum light. You have good air movement. You're keeping your humidity between 40 and 60%. One thing I will warn you about, because one of the most common mistakes in soil is overwatering. Plants need oxygen, and they bring it in through the roots. So if you overwater your plants, it fills up the pore space, and it'll start to suffocate the roots. So actually, it's not overwatering that kills the plant, it's lack of oxygen. So along with that too, for dissolved oxygen in the root zone, when you water your plants, make it a thorough watering, so that water is draining from the bottom of the pots. I'd like to say about 15% leachate, they call it. 15% of what you put in coming out the bottom, and then let them dry out, almost completely dry, before you give them another watering. There are some people that think, I'll just give it a little bit of water all the time, and what you're doing is you're creating little wet zones in your pot where you can start getting anaerobic fungi. Anaerobic are the bad guys. That's the root rots, the Pythium, the Rhizoctonia. They grow in stagnant water without oxygen. So if you have little anaerobic zones, you're going to start building up a zone for root rot, and then the plant can take up water and minerals. So you think you have to water it more because the root hairs are dying. So that's one of the common mistakes. The most common mistake in hydroponics isn't overwatering, it's over-fertilizing. You think, well, if a little is good, then twice as much is twice as good. Not true. You want to keep things nice and mild, because the more salts that you put in, the more fertilizer, the more it restricts the uptake of water. or minerals too. And that's where you get the fertilizer burn, because the plant it's too salty. The plant can't take up enough water. But lucky thing with hydroponics is if you do overdo it, then it's really easy to fix it because you can just add more water and dilute it down. Whereas soil's a little bit tougher. Along with that, I would recommend with your base fertilizers for hydroponics that you start with a half-strength nutrient. Because every base fertilizer I've seen or even made in the past has luxury levels of nitrate and nitrogen. And because when they do that, you get this big top growth. So everyone says, oh, look how good my plants are growing. The problem is if you overdo it with nitrate and nitrogen, it takes about 25 to 30% of the energy of photosynthesis just to assimilate the nitrates, whether the plant needs them or not. There's a myth out there that, well, I'll just give them a whole bunch of fertilizer, they'll just take what they need and leave the rest. That's not true, especially with nitrates. You give them more nitrates than they need, you'll stimulate the plant to make enzymes to assimilate those nitrates. And you give them some more, they'll assimilate those too. So they burn up the energy in top growth, and it restricts the root growth. Also, if you overdo it with nitrate and nitrogen, you can literally delay or even prevent flowering. So that's why I recommend during vegetative growth stage, start at half strength, because at least you know your nitrates are going to be in the adequate level instead of in the luxury zone. Now, one of the first products we're going to talk about today is the nitrogen. During the first half of a plant's growth, they assimilate about 80% of the nitrogen that they're going to need for the whole life of the plant. All right? So that's why most grow formulas are proportionally higher in nitrogen. Now, there are some plants are heavy feeders, and other plants are very efficient feeders, even in this, just different strains of plants. So you might have one plant that's a heavy feeder, not getting enough nitrogen, and you can start to turn pale green or yellow, or general yellowing of the plant. But the plant right next to it might be nice and dark green. So if you want to spoon feeder, you want to treat a nitrogen deficiency, then you want to use a product like this. This is the ammonium form of nitrate, nitrogen, not the nitrate. This is safe even to use as a foliar spray on your plants, just for spot treating. The ammonium form of nitrogen, if you spray it on your leaves, it'll be absorbed through the tissue, and if it is a nitrogen deficiency, the plant will start to respond within 2 or 3 hours after treatment, that quickly. And you will see, if you know how to read your plants, you'll see a difference in 2 or 3 days, for sure, if you're paying attention. But you can't spray nitrogen on leaves. It's foliar, it's carcinogenic. It starts to make nitrites, which are very unhealthy. In fact, in Europe, you could have all organic gardening, but if they do a leaf test and your nitrate level is too high in the leaf tissue, it loses its organic certification. Even if you did everything right, just because you overdid it with organics that were too high in nitrates or too available to the plant. But ammonium nitrogen is not toxic. It's absorbed easily. You can use it at the roots or you can use it on the leaves. So if you're just spoon feeding, we're literally talking a 1/16 of a teaspoon per gallon of water. Mist that on the plant and it'll start to come back. You could use your grow formula at the roots instead, and they'll fix it, but not as quickly. Or you can even use something like Kelmeg, but it has nitrates. Kelmeg has calcium nitrate in it, so you don't want a foliar spray. You could use it again at the roots, and they will respond and green up again, but not as quickly as a foliar. So these are the herbs and spices. You might not use them every day. If you had a little bit like this on your shelf, it's nice to have it when you need it. Just to kind of give your plants a little bit of help. And even during flowering, we try to reduce the nitrogen during fruit and flower production because we don't want the energy to go into growing leaves and stems. We want the energy to go into the flowers and be stored in the fruit. So toward the end of growth, a lot of times people do flushing. And the first thing that goes is the nitrates, because because they're very water soluble. And the plants will start to develop a nitrogen deficiency. Not bad if you time it right. If you time it just right, you start to get a little yellowing, you're still going to have really high quality. But if you go a little bit too soon, you might need to, they need that nitrogen to make chlorophyll to be able to harvest the energy from your lights to make the sugars. So if you don't time it right, you might want to just give it a little taste of nitrogen to keep it green until the right time. If you go too soon, and in that case, again, the ammonium nitrogen is not going to take away from the energy of the plant to make the flowers, where the nitrates would. So this is just a nice supplement. Have it on the shelf. Use it if you need it. If you don't, you just have the peace of mind that if you need to give the plants a little bit, you can do that without them stretching or without or taking away from your quality. That's probably a little more than I wanted to spend on nitrogen already. Any questions about nitrogen? It's ammonium or nitrate. Those are the two forms that plants like the most. In hydroponics, the nutrient formula, they'll have about 90% of the nitrogen in the nitrate form and no more than 10% in the ammonium form. By the way, are any of you using CO2? Yeah. Carbon dioxide supplementation? Okay. There's something that I learned recently, almost by accident, that if you're using high levels of CO2, say above 750 parts per million, which isn't that high, but 1,000, 1,200, the plants will take in the carbon dioxide instead of the nitrate nitrogen. It prefers to take in that carbon dioxide. So those free nitrates are going to accumulate in the plant. And those could, instead of being changed into proteins and enzymes and flavors, they'll just accumulate in the vacuoles and free nitrate nitrogen in the plant. And that can contribute to off flavors. So if you're using high CO2, you're going to want to try to flip the balance. You're going to want more ammonium nitrogen and less nitrate nitrogen. And you'll get as much as 18% increase in protein production. So it's just one of those little tips. One of these days I'm going to make a nutrient specifically for used in a high CO2 environment, and I'll change that ratio for you. But that's another place where it'll come in. If you're using CO2, it'd be nice to have a little ammonium. Cut back on your other fertilizers, add a little ammonium, and the plant immediately will change it into amino acids and enzymes right through the roots, instead of having to use up the energy of photosynthesis. I'll even spend more time on that. Okay, let's go to the next one. A bloom formula. During bloom, plants need more phosphorus and potassium. That's why you see most of the bloom formulas out there. You're going to have a higher phosphorus-potassium ratio and lower nitrogen. And there are also pK boost formulas, because if the plant's taking in more phosphorus and potassium, they're going to deplete it more quickly. So sometimes you want to put back in what the plant took out. So you keep your potassium to nitrogen ratio high. And that's the key to good quality. If the plant's pulling down the potassium and not taking down the nitrogen, then that potassium to nitrogen ratio gets tighter and it affects the final quality. You'll start getting tomatoes, you'll get watery fruit, low sugar content, poor shelf life. And also have a lot less stored sugars in the plant, so it won't be able to fight insects and diseases as well. So you want to keep the potassium to nitrogen ratio high. The pK boost will do that, but at the beginning of flowering, plants want more phosphorus. At the middle to end of flowering, plants want more potassium. Phosphorus is the energy element. It is part of the energy currency of the plant. When the plant does photosynthesis, you think it's making sugars. It is. That's just a store. But when they want to release energy for growth and reproduction and making the fruit and flowers, they have to change those sugars into exchange that energy into phosphate bonds and release them. That's the energy currency. So phosphorus is going to energize rooting early on. And it's going to energize flowering early on, so that there'll be earlier flowering and more flowering sites. That's why you're going to see a lot of phosphorus in a lot of the fertilizers you use. But toward the end of flowering, they don't need all that extra phosphorus anymore. They just need adequate phosphorus. You give it too much, get a phosphorus toxicity, it shows up as a zinc deficiency. And that can affect the whole flowering process. Hopefully it's not going to ruin your crop, because it's, by the time you get the phosphorus toxicity, you're ready to harvest. But the idea is, why give it what it doesn't need? So early on it needs more phosphorus. Also for early rooting. In commercial production, they don't just have a grow and a bloom formula like what we have. They'll have a starter fertilizer, then a grow, then a maintenance blend, then maybe a boost formula. And that's standard for greenhouse production and commercial production of crops. The only difference between a grow formula and a starter fertilizer is that a starter fertilizer is higher in this, monoammonium phosphate. That's what makes it a starter fertilizer. So at transplant, for those first 3 weeks in growth, if you give it a little extra monoammonium phosphate, it energizes the rooting and the establishment of the plant. I did some experiments in the lab, and just a small amount of extra monoammonium phosphate, I saw 20% more roots in a research lab at transplant. So I went to the fertilizer manufacturer. So, well, why don't we do that? Why don't we have a starter fertilizer, just like professional growers do? You just change it with a little extra phosphorus. And they said, well, we can't justify having a whole bottled nutrient that a grower would only use for 2 or 3 weeks, and then be sitting on the shelf the rest of the time. So they just turned me down flat, even though that's standard operating procedure in commercial production. So here is your compromise. You can use your half-strength nutrient, just sprinkle in at the most a 1/16 of a teaspoon per gallon. And you only use it for a few weeks. And when you transplant, you'll see the difference. Or at the very, very beginning of flowering, the transition into flower, sprinkle in a little extra there, just like the herbs and spices. But then don't keep using extra phosphorus, because once you get the flowering process going and get more flowering sites, the phosphorus has done its job. And they just need to keep the energy flowing, and that's in your nutrient. It's already high in phosphorus, so don't give it extra. And you'll get better tasting at the end. I think a lot of times when people complain about off flavors, like especially in hydroponics, I think it's mainly because it's being over-fertilized. Either too much nitrate or too much phosphate. I think those are the two main contributors to that problem. But if you can just spoon feed your plants, you can have more flavor and more aroma if you're giving them balanced nutrition. So people that think that growing in soil are going to have better flavors, you might. But if you know what you're doing in hydroponics, you can have just as good, and I think maybe even better. It's a scientific fact, by the way, that herbs that are grown hydroponically have 15 to 20% more aromatic oils than field grown. More aroma, more flavor. And I've also done tests with my EC where I make it a little bit salty, create a little bit of stress, and I had the strongest flavors, the darkest colors, the richest aromas on those particular plants that I was experimenting, the ones that do it. So stress is good. If the leaves start to curl under a little bit, that's okay. The plant's going to be making antioxidants to fight the stress, and those things are good for us. They improve the nutritional value of food, vitamins, improve the medicinal value of medicine. But if you overdo it and the leaves start to curl and turn brown, now you're actually hurting the plant, and the plant will not be able to produce those other metabolites efficiently. So a little stress is good, too much will put you in the hospital. But if you're going to stress the plant, do it by giving it what it needs, not by giving it what it doesn't. Don't put table salt on them to stress them. Give them some phosphorus and potassium instead. Oh, by the way, this particular phosphorus, if you look at the middle number, 61, this is the most pure form of monoammonium phosphate that there is. It's when you put this in water, it'll dissolve crystal clear and be immediately available to the plant. And also the ammonium that goes along with this phosphorus, in nature, it actually aids with the uptake of phosphorus. That's the form plants like the most. But this has been purified. This would not be organic because it's this is a mineral salt, but very highly purified. if you want to make monoammonium phosphate, I'm talking to the all organic guy here, you could do it. You could take 1 square meter of manure, add a bag of rock phosphate, turn it 3 or 4 times, or 2 or 3 times in a 2-month period. It will, rock phosphates will be converted into monoammonium phosphate. And that would be good for the plant. It would do the same exact thing that this would do, but this is the pure one where you're sprinkling a 1/16 of a teaspoon in water and feeding the plant. The other one would be all organic, though, and certified. To the plant, though, it's the same thing. They love that ammonium with the phosphorus. Just so, if you want an option, you can do that. All right. Next one, like I said, at the beginning of flowering, that extra phosphorus is going to be good. Later on, though, don't need the extra phosphorus, but they do need potassium. During heavy fruit and flower production, the plants can deplete potassium to deficient levels in as little as 3 or 4 days. And sometimes it will show up as a hidden hunger. You don't see symptoms of potassium deficiency. It affects the quality, though. Potassium is the quality element. It's the catalyst for carbohydrate metabolism. So sometimes the gardeners will come in and say, Harley, my plants were growing great. They started to fill in with lots of flowering sites. They were starting to fill in, and all of a sudden they just stall. For the last week, I've been watching them, and it doesn't seem to be doing anything. I don't see barely any difference for 3, 4, or even more days. It could be potassium deficiency because it depleted that catalyst that they need for transporting those sugars. So you give them a small amount of this potassium supplement then, maybe with the watering, not even adding it with the fertilizer. If you fertilize and then water, just take one of those waters, just add a little bit of the potassium with it. You're putting back in what the plant takes out, turning back on the carbohydrate metabolism, and those sugars will be transported to the flowers and they'll start to fill in again. It's very simple. Just again, it's only nudging your plants in the right direction. It's not changing everything. It's just changing one thing a little bit. So that's it. Oh, by the way, for the certified organic growers, this particular potassium sulfate qualifies as OMRI, certified organic, because there's no chemical extraction process. This comes from a very pure mine source that is certified organic. So you could use this as a supplement and not feel like you're ruining all the work that you put into it. It also dissolves very well in water for hydroponics. And this is what commercial growers actually use as their boost. They don't use monopotassium phosphate like what all our PK boosts are. They'll use potassium sulfate. So again, we should be learning from the pros. We're maybe the hobbyists, but a lot of us want to take our hobby to the next level. At least I have for a long time. I may not be worried about getting extra 10% yield, but I want the best of quality. And this is one of the areas that will affect that best of the best quality and the flavors. All right, next one here is kelp. Any of you using seaweed extracts now?
I tried, didn't like it.
You didn't like it? Anybody else using seaweed extract, seaweed? Yeah. If you were going to add just one thing to a feeding schedule, just one thing, out of all the products up here, this is the one I'd recommend because it has several different uses. You can use it as a seed soak. This is rich in hormones, natural growth hormones, and it's rich in trace elements that are beneficial trace elements. They're not the ones that are in your base nutrients. They're just beneficial ones. So if used as a seed soak, you'll get earlier germination rate for your seeds and earlier germination. This is soaking them overnight. If you use this at the roots, this has cytokinins in it. It's very high. That's the hormone that stimulates cell division. In biology, cytokinesis means cell division. So cytokinins are the hormones that stimulate cell division. So you use this at the roots, you're going to get more lateral root growth, more root mass. And this is the main ingredient, some of the expensive root stimulants out there. One of the main ingredients. If you use it as a foliar spray, you're going to get more lateral bud development and branching. It'll break the top growth, but you'll get more side branching. Also, cytokinins literally pull nutrients into the tissue if you use it as a foliar. If I had a leaf and I put 1 drop of water that has cytokinins on it, cut the leaf off and put it on the table, that whole leaf will turn brown except one little island of green where the cytokinins were, because it literally pulls in the sugars, the amino acids, the nutrients into the tissue and keeps them juvenile, keeps it green. So the one thing you have to be careful with seaweed though, especially this one, because this one is going to be extremely potent. I mean, you put this in water, it's day 1 of shelf life. It has been sitting in water for a year in a warehouse somewhere. So be careful, don't overdo it with this, you can burn your plants. You want the low dose. Also, if you do use it as a foliar, use it no more than once a week. That's at the most once a week. Once every 2 or 3 weeks will still have a beneficial effect on the plant. If this is the one you want, the less is more. But you should see a difference though. And should have a downstream effect too, because you're not going to spray it on flowers. You're going to do it during vegetative growth and early flowering, but it has a downstream effect because it'll help pull the nutrients into those developing buds. So it will have an effect with tighter internodal length and improved colors and aromas and flavors. That, because of that, and also because of the trace elements from the seed that are in here. That may be missing from your soil or missing from your water. If you want to try this, you say, well, okay, I like the kelp. How can I improve it? Virginia Tech did a 10-year study on biostimulants. And in their research, they found that 5 parts humic acid with 2 parts seaweed worked 50% better than either product alone. 5-to-2 ratio. 5 parts humic acid, 2 parts seaweed. Humic acid is an intermediate chelator. It holds on to some of the cation minerals the plant needs, makes it easier for the plant to take them up. So it activates enzymes. It's like the amplifier. So this, you can think of the hormones in seaweed as being the signal telling the plant to grow, more roots for example. You can think of the humic acid as the amplifier. Put the two together, you've got a boom box, signal and amplifier. Either one alone will be beneficial. Do any of you use RO water? We're supposed to add, but a few of you. One of the first things I would add would be the humic acid. In nature, humic acid, humic and fulvic acids at the roots help neutralize pH. They'll raise the pH of acid soil and lowers the pH of alkaline soil. That's nature's way. They also work together to help with the uptake of iron by the plant. So if you're using RO water, you've stripped out all the minerals that were in the, whatever you want to call them, contaminants that were in your water. And some of those contaminants are actually good for plants. So if you strip those out, also you're stripping out all the bicarbonates, so there's no buffer for pH. It's pH can spike or it can crash really easily with RO water. And if you're using it, you've seen it. Everything looks fine, all of a sudden shoots up, or all of a sudden it crashes. Scientifically, I'll give you the short version here. During rapid vegetative growth, the plants are taking up proportionally more nitrates. Nitrate, nitrogen, those are negatively charged ions. So to keep balance, you have to get rid of the negatively charged ion, the OH, bicarbonates, so the pH goes up. So they exude bicarbonates or hydroxyl ions from the roots and the pH goes up. During heavy fruiting and flowering, they're taking up more what? Potassium. Those are positive ions, so they have to get rid of a positive ion, hydrogen ions, pH goes down. So if there's no buffer, it can swing pretty wildly. If you get up above 6 in hydroponics, you know, you get up above 6.5, you're already starting to ask for a problem with iron deficiency. You get above 7.5 pH, you're all the metals, copper, iron, manganese, zinc. Yeah, they're trace elements, but they're essential elements. they turn on very important enzymes for metabolism and plant protection. So you want to kind of keep the pH in the right zone. So to avoid swings, if you add a little humic acid first before your fertilizer, you're going to help buffer your pH, and you're also going to add in about 62 beneficial trace elements from those ancient compost piles where they got the humic acid from. And you put the two together, then you got it's even better. You got those biologically active molecules plus the chelated minerals. If you're going to use kelp as a seaweed or as a seaweed as a foliar spray, I would recommend, instead of using the humic acid, which you'd use at your roots, use fulvic acid. And this is organic, same as the kelp. Fulvic acid is the more highly refined part of the humic. Fulvic acid is. These are smaller molecules. They will attach to the color in here, that reddish color, iron. A lot of times, if the pH isn't exactly right, plants will start to get an iron deficiency. You'll know because it'll show up in the top growth as interveinal or as chlorosis. It starts at the stem and works its way out in the leaf. Usually, though, you correct your pH and it will green back up. Because iron is a catalyst for the formation of chlorophyll. But if you want to do a quick fix, take a little bit of fulvic acid, mix it in water. It chelates, like a chela means claw, so it surrounds those iron ions like a claw, literally transports it through the cell membranes into the cell of the plant, and releases it inside the cell where it's needed the most. So if that happens, that iron will stimulate the formation of chlorophyll, which absorbs the light energy, it'll green up your plants. And if you start getting more chlorophyll being built up, it's going to trigger the genes to make more chloroplasts. So the plant will literally be able to harvest more of that light energy and turn it into sugars. That's part of nature's way. We call it iron homeostasis. So if you can improve the uptake of iron, which is one of the limiting factors in soil, then you're going to improve the whole growing process of the plant. So this is a really good combo for foliar spray, where the humic acid, these are larger molecules, and they'll make a bridge in your soil between your clay particles and your minerals. So it'll make it easier for the plant to take up the minerals. Because if you have clay in your soil, it can hold on to those fertilizer salts so strongly that the roots can't get them up, can't take them up. But if you add the humic acid, it makes a bridge, the plant can take them up pretty easily. So there's another. This is a nice combination here. These just the seaweed, humic or fulvic acid. You just add that little bit to your feeding schedule. You should see a difference. Oh, also, I just wrote an article for Maximum Yield magazine. It was in June. It was called "Here Comes the Heat." Virginia Tech. I didn't discover it. I just get to put in a good word for Virginia Tech because they helped me out. They found that 5-to-2 ratio stimulates the plant to make 50% more of an enzyme. The name is, for the camera, is superoxide dismutase. It sponges free radicals from stress. If there's no stress, everything's perfect, the plant makes enough superoxide dismutase. But you get a little light stress, UV stress, heat stress, drought stress, salt stress, the plant can't keep up with those free radicals. But if you use this combination before the stress happens, 50% more of that enzyme. And so the plant will protect the cell wall membranes, it protects the chloroplast membranes, that's where photosynthesis happens, and it protects the mitochondrial membranes, that's where the metabolism of the sugar happens. So you're protecting the engine, the power plant of the cell. So it's like, think of it as an engine. You know, if you run out of oil, you burn your engine out. Well, that combo is sort of the oil for the plant to protect the membranes from being attacked by free radicals. So just interesting side note. So it adds an extra benefit of stress tolerance, and that could translate into yield. Because I know in my garden, when everything is getting big and it's starting to grow into the lights a little bit, And especially in the summer, I have a hard time controlling temperature. And anything I can do to give the plants a little bit of an edge is a good thing. You know, there's a limit, but at least they'll recover more quickly from the stress if you can add that combo. Okay. How am I doing on time here? Is there a time limit? Or?
30. Well, you're 35 minutes in right now.
Okay. So we're doing okay. Any questions so far? I don't want people to start glazing over already. No questions? Everyone's kind of following it? Good.
So, all right, one thing. Like,
Yeah.
if I had 120 gallons of water, how much would one of those bags work? That's what I work at, is 120 gallons to 150 gallons.
A small bag, remember, you're not going to be using it all the time either.
No,
Remember?
that's right.
But let's say the potassium that you're only going to be using to top off during heavy flowering, this will make 200 gallons.
I'll make 200 gallons. I'll be using like over 3/4 of the bag of that.
Yeah, with a little bag.
Yeah.
So you probably go to the bigger one. This is 800 gallons, and there's one size up from that too. I kind of like the idea they have the small sizes though, because now it's your herbs and spices. You're only adding you can say, I'm just going to sprinkle a little bit. You know, I'm not pouring in bags. I'm not throwing my fertilizers out of balance. I'm just keeping them in balance. Big difference.
I can see where some of those become useful.
Okay, so let's move on to the next one. This one's kind of a unique product, but let's go ahead and talk about silica. I also wrote an article in Maximum Yield on biogenic silica. Most of the silica products here in the store are derived from potassium silicate. Silica is not an essential element, it's a beneficial element. It works along with calcium, helps strengthen the plant, so the leaves stay a little more upright, harvest energy a little better. Also, if the plant's under attack by a mold spore or powdery mildew, the plant will mobilize, will take the silica right to the point of infection, the point of attack, and crystallize the cells around the point of infection so that the disease can't spread as easily. So it's kind of a part of the systemic induced resistance of the plant, its immune system. Well, the potassium silicate out there, though, very water soluble, but it is very high in pH, very alkaline. And personally, I'll use potassium silicate as my pH raise in hydroponics. If I overshoot a little bit, when I'm a little bit too low in my pH, when I'm adding my acids, I'll add potassium silicate to bring it back up. Because at least I feel like I'm doing something beneficial for the plant. I'm not just correcting my problem. But I have well water, so my pH is high to start with. I don't want to raise my pH. Well, this is biogenic silica. It is pH neutral. It has a pH of about 7.0 to 7.2. This is organic. This is extremely friendly for microorganisms. In fact, this exact same grade of silicon dioxide here is used as a carrier for microbial inoculants to inoculate the soil with beneficial microbes. Also, this product commercially is used for water filtration. These are very, very fine particles. When you put this in water, only 25% of it's going to dissolve. The rest of it's flowable, get trapped in the roots. But those little tiny particles, they won't clog up emitters or anything, but those particles have little holes in them. Look at them under a microscope, like a little sieve that the water can flow through. That's why they use it in filtration. But as the water flows through these particles in the roots, it's trapping some of the cations, some of the iron and copper and manganese and zinc. And that stimulates the metabolism, not only of the plant, but of the microbes. If it stimulates the microbes, then the microbes in the roots there that are living on this as the perfect house for them in the roots, they're going to be making organic acids, they're going to make iron more available, they're going to be making rooting hormones right there in the roots. So this goes way beyond the benefits just of silica to the plant. It's beneficial, but the fact that this is very friendly for the microbes and will help them with their metabolism. They've used this as a launching station back and forth between these particles and the roots as they grow and reproduce. So this is unique. There's no product here in the store that's similar to this. And it's not, like I said, not 100% soluble, but the particles that get trapped in the roots are going to be a slow-release silica. And by the way, there's no such thing as a silicon toxicity. You can't overdo it. The plant just takes up so much, and the rest of it that's trapped in the roots is only going to do good. It can't hurt the plant. So you could literally use this with every watering if you wanted to, and you don't have to worry about it locking up other minerals or causing problems. If you overdo it with the potassium silicate, you will lock up nutrients. You've probably seen it. You put it in the water, you see this milky cloud developing. That's because of those chemical reactions with the pH. And afterwards, some of that's going to fall out of solution. This is an alternative. Okay, let's see. Yucca. This is why I joined NPK. When I saw this display and I saw Yucca, I said, these guys know what they're doing. Because when I was making my first biohydroponic fertilizers, Yucca was my secret ingredient in the mother plant, in the part B, because it really helps. It's a wetting agent. It's a natural wetting agent. It makes water wetter. So if you add this to your water, the water will disperse through the whole root zone and water all the fine root hairs. Normally in soil, these are so many soil growers, or soilless mix, when water will follow the path of least resistance. So you water the plant, it's going to follow those same channels that went through before, through the growing medium and out, or around the edge of the pot. And if you'll look at your roots when you harvest your plant, you can see where those channels were, because you'll see strings of roots and no roots in pockets all through the growing medium, because the roots will follow the water. Now you add a little bit of Yucca to the water, it breaks the polarity of that water molecule, so it spreads out in the grow zone. And the roots will still follow it, but you're going to get a lot of more fine web or sponge of roots in your growing medium. You'll see it at the end when you harvest your plant. So one of the things they say this does is it helps stimulate root growth. But, you know, I've talked to the biochemist, but I think really what's going on is the water is being dispersed more evenly, and that's what's improving the root growth, not some magic ingredient in the Yucca. If you do any foliar spray, add a little bit of this to it. If you're doing your humic acid, or your fulvic acid and seaweed, add Yucca with it. Instead of the water beating up on the waxy surface of the leaf, it'll spread out in a film, and it'll be more evenly absorbed by the tissue. Otherwise, you get little spots on the leaf where those salts were. You can actually see little spots there. In fact, in the past I've seen this. Is that powdery mildew? It might have just been a little bit of spot from water spots from the water. So you use this, you won't have the water spots. You'll get a nice film. If you have to use some kind of an insecticide spray, then add this to it too, because they'll spread out in the film. It'll coat the bugs better. It'll coat the eggs better. So it'll make your insecticides, your organic ones or others, they'll make them more effective. And this is 100% Yucca food grade. So this one little bag will treat 1,000 gallons of water. So do any of you do flushing? You do the flush at the end? This is it. This is what you want, right here. If you look at some of the flush products in the store and look at the active ingredients, a lot of them you'll see Yucca. But you'll be like 2%, 2% Yucca. So this one though, you were talking about the sprinkle. This one, 1/16 of a teaspoon for 5 gallons of water. And when you stir that up, it'll foam. And some people that make compost teas, I don't know if you ever make them, you make those. Yucca is a good ingredient to add it last. Last thing, because it will foam up. You get kind of foamy. Commercial growers will use this and put it in their irrigation water because it keeps the drip emitters clean. It actually, it's not like soapy, but it's like a natural saponins. I guess they could use it to make soap. It'll clean the roots too, and it'll wash away it. The reason I use it though is because it helps to keep the mineral salts and the organics together in suspension. And the concentrated salts and the organics, they really don't play well together. They have opposite characteristics. But you add a little bit of yucca, give it a little shake, everything stays in suspension really nice. So when I made mother plant nutrient in the part B, I had the mineral salts in there, the phosphates and the sulfates, but I also put in seaweed extract, humic acid, and B vitamins. But it almost wanted to coagulate in that salty concentrate. But I added the yucca, give it a little shake, it was beautiful. So it might settle out a little bit over time. It's sitting on the shelf, shake it this much, it's foaming, everything's back in suspension to feed the roots. And then when I water it, because of the surfactant, it's going to spread out to all the roots, so I'm getting that seaweed and the fulvic and those nice trace elements out to all the root hairs that are in the pot. So the plant's using all those minerals more efficiently. And people are coming back saying, I love that fertilizer because my plants have never looked so healthy. And I know that part of the reason is because I put some of this in there, just a tiny, tiny amount in the concentrate. So that's a good one to have on the shelf. It'll last a long time, especially for flushing. It'll wash away those salts. In fact, I'm on tape here, but I rarely, if ever, flush because I'm spoon feeding my plants. I'm just giving them, I'm not over fertilizing. I'm not letting there be a buildup of mineral salts over time. It doesn't get salty and crusty. And especially when I was using the mother plant with that yucca in it, because every time I watered the plant and the water went through, I was getting rid of the excess salts. So I didn't have to flush at the end. The only time I flush is if even one element builds up to toxic levels. Then I'll flush. If there's too much zinc, flush it. If first aid maybe, if I'm having a problem, I don't know if it's a deficiency or toxicity, I'll flush and then put fresh nukes. But some of the growers out there that swear, you have to flush, right? They say you have to, otherwise it tastes terrible, the product. They've tasted some of the produce that I've grown, and they'll say, these are connoisseurs, right? They really know their stuff. You flush, don't you? I can tell. I can tell by the flavor. I can tell by other characteristics. And I kind of want to bite my tongue and say, hell no. Sorry, never mind. Instead, no, I don't say that. I just say, we did it right. But because if you tell somebody, if you believe it, you'll taste it. Let's put it that way. And I'm not saying not to flush. I'm just saying that this is a good flushing agent if you do, but if you're properly feeding with the nutrients all the way through the growth stage, the need for flushing is greatly reduced, if not eliminated. That's all I'm going to say. So continue to do it if you want to. There are some benefits, but there are other strategies than one. Okay. Oh, B vitamins. They're just about in all the biostimulant products. It stimulates metabolism. This particular one is 1% B1. So very potent. You add it to water, it's full potency. It stimulates the metabolism of microorganisms in your soil. So when those microorganisms are metabolism is, they're going to grow. They're going to divide. And it's when they divide, pop, dividing, that's when they make the digestive enzymes and all the good things for the plants. So this will help stimulate the microbes. Within hours in soil, probably 90% of the B vitamins in here are going to be used up by the microbes. Not a bad thing, it's a good thing. The rest will be leftovers will go to the plant. In the last couple of years, they've proved that even one treatment, one dose of this B vitamin blend on the roots will help protect the plant for 10 days. And what it does, it stimulates the plants. It's called systemic induced resistance. They've just discovered this in the last 2 years in plant science. Although Super Thrive, those guys have known it since the 40s. They just didn't really know why. And none of the scientists could prove it, so they said, this stuff doesn't do anything. They finally proved it 2 years ago, after 1940s for Super Thrive. sorry. Sometimes the scientists have to catch up with the plants. But the gardeners who have been using it all their lives say, yeah, it really helps. And then the scientists say, no, it doesn't do anything. It does. They finally figured it does. They used to think it prevented transplant shock. But the reality is, the systemic induced resistance that it stimulates puts the plant on high alert. It primes the plant, so it's sensitized, becomes highly sensitive. If there's any problem with stress, or if it's under attack by Pythium, or it's under attack by a little bit of powdery mildew, the plant's natural immune system will respond just like that to start to fight it. Where if it didn't have that, it wasn't primed, it could take hours or it could take days for it to start to really recover. And by that time, the problem is spread. And the stress has done more damage to the plant. It's harder for the plant to recover. So if you're doing transplanting, it's not going to scientifically reduce transplant shock, but no matter how careful you are when you transplant, you're going to break some of those microscopic root hairs. That's just going to happen. And then that opens the plant for infection by pathogens. Well, if you dip your plants or treated them with some B vitamins first, they're going to be able to fight that off faster and recover quickly. So if you didn't have it, it might take up to 2 weeks for the plant to recover if it was under attack. With this, it will be 2 days, and it will be right back and growing, developing new roots. So they finally figured that out, and they didn't even find it in the United States. It was over and I think it was in some scientific research in plant science in Korea, where they finally proved what we've all known as gardeners most of our lives. I mentioned there's a lot more going on, because if you're stimulating those microorganisms are making some other metabolites that are going to, again, improve the plant's systemic induced resistance. So there's a cascade of positive effects. And I will say this, if you work with nature, there are going to be positive side effects you did not anticipate. You work against nature, more than likely, sooner or later, there's going to be negative side effects. I can say that with 20 years of experience. So a lot of my discoveries were accidental after the fact, when I made observations